All right, let's finish this one up. Okay, so here we have triangles ABCD. And we are going to start off talking about how we can get from A to B. So A to B, and it says the transformation. So it doesn't say we can do multiple things. So basically, you should see that this is a dilation. So this point maps here, goes up 1 over 1, 2, 3, 4, up 1 over 1, 2, 3, 4, up 1 over 1, 2, 3, 4. Okay. And then these ones just go straight up the line. Boom. So I can have, I know the center of dilation is at 10, 7. How much does it grow? Well, do I pick a hard way or no? Okay. Basically, this is 1, 2, 3, 4. We can do this dimension. And now it's 1, 2, 3, 4, 5, 6. So it goes which way? From B to A or A to B? That maps A onto B. So I know it's going to be growing, right? So I wouldn't say the scale factor is 4 to 6 or 2 to 3 because that would be shrinking, right? From A to B, it goes scale factor of 3 to 2 or 1.5. So I would say this is a dilation with a scale factor of, fine, already wrote it. Why do I gotta do it again? But I also need to say through the center of dilation or with a center of dilation at point 10, 7. Nice. So that is a complete answer. To get from A to B, it's going to dilate 1.5 times. The center of dilation is out here at 10, 7. Beautiful. All right. How do I get a series of transformations? So there's actually more than one way. How can I get from B on to D? Okay. From B to D. All right. You guys, people had different answers. That's fine. I didn't say only 2. You can do this with only 2, but you could also do it with like 3 or 4. So just rotating it. What if you think we rotate it like this way, about this point, right? 90 degrees. And 1, 2, 3, it would look like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Is that 6? 1, 2, 3, 4, 5, 6. It would look like this, right? Ooh, that's actually kind of cool. All right, so now what I would have to do is reflect it. Its distance right now is 1, 2, 3, 4. Let's see. 1, 2, 3, 4. I didn't even think of that. So yeah, you could rotate 90 degrees about the point -2, 4. Which way? Counterclockwise. And then reflect it across the x-axis, right? That's one way to do it. Let's do another way. There's a reason why C is there. Let's reflect it. Reflect B across the x-axis. Boom. It would turn into C, right? So now we can literally see what it would be. So if I want to get to C to D, I could put my finger or whatever on this point right here, which is an invariant point, because this is like the long part above the point kind of directly, and this is a long point apart point about the point part whatever. I'm gonna not even say what I was trying to say. So I could rotate it. Then I will get it there. So then rotate the image 90 degrees. Which way? This way with the clock. Clockwise. About the point would be the origin. No, I wanted this to stay here. If I did if I did 90 degrees, then it would go up there. I need to stay where it is and just go further down. So about the point, that's going to stay the same. The invariant point, -2, -4. Boom. I think that's the easiest way to do it is reflect it first, then rotate it. The other way I showed you is rotate it first, then reflect it. You could even like flip it, rotate it, translate it. There's lots of ways. I think this is the easiest way. Make sure when we describe transformations, you tell a point that line that it reflects across, the line reflection, and a rotation. You want to say a direction, a degrees, and what is the point that we're spinning it around. Okay. And lastly, let's look at part C. Okay, triangle D is mapped onto triangle E, which is not mapped by a rotation of 100 degrees about some point X. And instead of saying XY, it's saying -X t plus 1. The image of M1 of point M, which is here, -2, -10. This thing's messed up. Look, this is 3, 4, 5, 6, 7, 8, 9, 10. This is -2, -10. Just trust me, that's what this shape is. So this point M is going to rotate 180 degrees, and it will go to -6, -2. Right? So let's connect them. Okay, -6, -2 is the location of M prime. Okay, the image M prime of point M, which is -210, has coordinates -6, -2. Find the values of S and T. So X marks the center, is the rotation center. And instead of writing it as the coordinates X, Y, they're going to say X is -S and Y is T plus 1. Okay. So let's talk about this. If it spins around, what do we know about rotation? It should be equidistant, right? So equal distance. We're going up 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Let's go up 4. 1, 2, 3, 4. Pretty sure X marks the spot that it would rotate around. Let's see. This would rotate. 1, 2. This would rotate down 2 over 1, 2, 3, 4, 5. Up 2 over 1, 2, 3, 4, 5. No. Here. Yeah. Pretty sure. 1, 2, 3, 4, 5. Okay. Oh. Ooh, y'all want a tip for the test right now? Your next test. So if this is M prime, this is M prime. This is, I don't know, G prime is across from it, right? So it's not the same order. Like the thing that's, never mind. I'll just give you another example another time. But what are the coordinates of this center point that we're going to rotate around? It is -4. 1, 2, 3, 4, 5, 6. -6. So you would get great credit if you knew that it is -4, -6, but this is -4, -6. We want to get it to be -4, -6. So what would I put in for S to get this to be -4? I would put that S is 4, right? Because if I put in 4 here, then what do I have? -4. So S is 4. And what would I put in for T in order to get -6? Is -5 plus 1 -6? No. It would have to be -7. T is -7 because -7 plus 1 would give us the coordinate of -6. So that's how you do part 11 of this. You map the points. You know that it's going to be equidistant from the rotational point. Find that equidistant point and just make sure that you're solving for S from the equation or situation it gave us. Cool. That's how you do number 11. Have a good weekend.